Oh, that's interesting. I wonder if there's some sort of statistical thing we could do about scores and seating placement, right?
Oh, well, I mean, we aren't
bands,
seated in
everyone's got
the
the band,
rows,
too.
though, so it probably is like.
Oh, that's true. That's true. All right.
It's also Bands of America. Everyone's got that.
All right. dy dx equals y over root 1 minus x squared. All right. All right. So the answer was A. All right. Getting into the lesson. So today we're doing 4.4a. 4.4a is the first day of this wonderful rule called LHopitals Rule. Now, there are like 40 different ways to spell LHopital. If you like to give your notes a title, I would just call it LHopitals Rule. LHopital can be spelled with an upper or lowercase l, and it can be spelled with or without an s in the name part. I personally always spell it with an uppercase L and no S. Your book spells it with a lowercase l and an S. So but if you go, like if you ever Google LHopitals, all the different spellings will show up. Like every site does its own version of how to spell LHopitals. So anyway, Miss Grimwald and I talked for a minute about doing this section because traditionally, LHopital, at least in our old book, did not come up until chapter 8. And in all honesty, I thought chapter 8 was an unusual place for it too. There's really no great place for LHopital. It doesn't have a good home. In order to do LHopital, you have to know limits and you have to know derivatives. So because you have to know limits and derivatives, it has to come up somewhere after chapter 3, right? So, but it doesn't, there's nowhere it really fits. It's its own thing. So this book decided to put it in chapter 4. Ms. Grimwald was like, this has nothing to do with anything we're doing, and I agree. It has nothing to do with anything that we've done in the past in this unit or in the future in this unit. It's its own little isolated 2 days of interesting material that you have to learn. And so we decided we're going to stick with it because this is a new book and we are going to trust the book. And so we were following the way that the book does it. And so this is where it falls. So today is LHopital Day. And Monday will be LHopital Day. LHopital today is not terribly difficult. It's actually, once you kind of get the hang of it, it's really not bad at all. Monday, we will get into the more complicated LHopital problems. So Monday is a good day to be here. Right? All right, but today is not so bad. Quick little note. I know the recorder's running, but that's okay. Quick little note. So today we're doing 4.4a. Monday we do 4.4b, which is the second day of LHopital. On Tuesday, we're skipping around a little bit. So on Tuesday, I think we're doing 4.7, but I don't remember the number. I think it's 4.7. It's optimization. So Tuesday we're doing optimization, which is max min with words. It's word problems with maxes and mins. So Tuesday is word problem day. It's all applications. Wednesday we are out. So all the calculus teachers, Ms. Johnson, Ms. Grunwald, and myself, all three of us are out on Wednesday. We're going to the College Board Calculus Workshop. Should be really fun. We'll come back with all kinds of great insights to tell you on Thursday. So on Wednesday, I am going to do a pre-recorded lesson on curve sketching that you're going to watch the video. It's mostly review. You're going to watch that's why we switched, because optimization is not. So I put the sections are switched around because I didn't want to put such a hard lesson on the day I wasn't here. So Wednesday's lesson's easy. It's mostly just review of increasing, decreasing, and concave up and concave down. And the only added little twist is being able to sketch the curve. So that's Wednesday. And then Thursday and Friday, we do antiderivatives, which is like the beginning, really, of chapter 5. But anyway, so it's Thursday and Friday. So then the following, so that's next week. So we have a lesson every single day next week. It's a whole week, all learning. The following week is the last week of the term. And it's only a 4-day week for you guys. So we are going to review, and test. So the last day of the term will be your Chapter 4 test. It is not retakeable. We don't retake and it says it in your syllabus, so nobody can argue with me because it's in print. We never allow retakes on the last test of a term because I'm not going to sit there and put 60 grades of incomplete for my grades and then have to arrange with the test center, which isn't open the first week of the term, to sit there and get 60 retakes done and then have to do 60 grade changes 2 weeks later, right? So we don't do it. We don't retake last test of the term. So we will take that into account when we grade and when we curve, that it's not retakeable, but it's not retakeable. All right. So that will be the last day of the term. So a week from Thursday. So there's only, after today, there are only 9 days left for term 1. And then we start in on term 2. Right? Okay. All right. Second warm up, I would like this on your whiteboards. There are six wonderful review limits. Let's see how well we do with our limits. While we are doing these, I'm going to play a little background music. 1, 3. Yep. Okay. So for the first one, you just plug in the 2, right? And you get 0 over 4. 0 over 4 is 0, right? So for the first one, the answer is just 0. Good. Which boards do we have? We got 1. We have that one. Were there only 3 groups working? Huh. Only 3. Okay, good. Perfect. So you all got the first one. Well done. All right. So for the next one, you had to do some algebra. You had to actually combine the fractions. Because when you plug in, you get 0 over 0. And 0 over 0 in limit world means keep going, the limit exists. So when you do your algebra, all you have to do is find an LCD, right? Clean up the fraction and plug in, and you end up with a limit of -5/4. All right, I'm going to quickly work this out. So limit is x approaches 0, multiply the whole top and bottom by 2 times 5x minus 2. So you get 2 minus 5, or 5x plus 2 over x times 2 times 5x plus 2. So now when you plug in a 0, you get, okay, we got to cancel some stuff. Let's, so 2 minus 2, so you get -5x over 2x times 5x plus 2. Now you cancel your x's and you get -5/4. All right, for the next one, you plug in the 5 and you get not 0 over 0, which means what's going on at x equals 5? What's on the graph? A vertical asymptote, right? So you are fully allowed to just write DNE in this unit for those because that's fine. All right, so well done with the DNE. Good, okay, 3 for 3. The next one, you get 0 over 0, which means keep going, the limit exists. So those of you who chose to just guess at all the answers, missed number 4. What did you guys get? You got a half. Good. And you guys got a half. And the answer was a half. So you had to, when you have these group problems, you have to rationalize top and bottom by multiplying by the conjugate, right? So you multiply by the conjugate and then you clean it up and you get a nice limit. All right, number 5. Horizontal asymptote. When the degree of the top is bigger than the bottom, the limit approaches infinity. So it's either infinity or negative infinity. You plug in the infinity and check the signs. In this case, it's positive. So I think I see that for that one. Yep. Good, you all got it. And then the last one, when the degree is the same top and bottom for a limit as x approaches infinity, it's the quotient of the leading coefficients, which is -3 halves, -3 halves, -3 halves. We all agree it's -3 halves. Well done. Good limit review. Why are we doing a limit review? because L'Hopital is all about limits. Today is a day about limits. So the question I have is, those limits were all great, but what if you had to find the limit as x approaches 1 of ln x over x minus 1? First question, what's the natural log of 1? Is that a question?
No, it's for sure.
It's for sure. What is it? Are you confident with that?
Yeah.
Heck yeah. Yes, it is 0. How do you know that the natural log of 1 is 0? What base is a natural log? E. So there's like a little invisible e here. E, does e to the 0 equal 1?
Yes.
Yes, then the natural log of 1 is 0, right? Okay. So yes, natural log of 1 is 0. What's 1 minus 1? So you get 0 over 0, which means keep going, the limit exists. How are you going to keep going? We don't know, right? What do we do with this? There's really nothing to do. So how do you find this limit? That's where our buddy L'Hopital comes in. So I'm going to show you the rule first, and I'm going to talk about it a little bit. So if y is equal to a rational function, and the limit of the top and the limit of the bottom are both 0, or the limit of the top and the limit of the bottom are both an infinity. The sign doesn't matter for the infinity. It can be plus or minus on either one. They can match or not match, doesn't matter. If the limit of the top and bottom are both 0 or both an infinity, then the limit of the top over bottom of f over g is equal to the limit of their derivatives. This right here, this beautiful thing, this is L'Hopital's rule. A couple quick notes about it. Number one, notice you are not doing quotient rule. It's not f prime g minus f g prime over g squared. It's literally just derivative of the top and derivative of the bottom. The other note, and this is an important one, 3 years ago, the College Board changed their requirements on L'Hopital, and now the College Board requires justification whenever you use L'Hopital. If you don't have appropriate justification, they do not give you credit for your L'Hopital. So, what is the justification? You either have to write this or this every single time you write a L'Hopital. So you either have to show that the limits of the top and bottom are both 0, or the limits of the top and bottom are both infinity. Every single time you do a L'Hopital. You should know that I tend to use the word L'Hopital as a verb, even though it's actually a name and a noun. The rule is a noun. L'Hopital itself is a name. But I tend to use it as a verb. So those of you who just walked in perfect timing. We just got to the beginning of the actual lesson. You missed a whole bunch of warm-ups. Welcome.
Sorry.
Yeah, it's okay. You're sorry. Maybe someone else will come in. Okay, so so those of you who just came in, don't start distracting. So if this is true or this is true, then this is true. This is L'Hopital's rule. I'll give you a minute to copy those of you who just came in. That was just of the board, right? I'm not in that picture.
You want me to pick another one?
Yeah, stand up, delete that one, take a picture of the board. I don't like being in pictures.
Oh, you're not.
Okay, good, thank you. Oh, welcome back. Okay. Why did you take a picture if you're going to write it all down anyway?
Well, just in case you wanted to switch it.
I am going to switch it in about 10 seconds.
Yeah.
Okay. And you guys know these are always online, right? I post the Smartboard notes every single day. So if you miss something, you can always just pull it up. Okay, we're moving on. All right, so here's what we're going to do. We're going to redo the same 6 limits that you just did in the warm-up, but now we're going to do them with L'Hopital. So I'm going to walk you through some of these. I'm probably going to walk you through all 6, and because I have others that I'm going to have you do on your whiteboards. So the first one, if we plug in a 2, what do we get on top? What do we get on the bottom? Not 0. We get 0 over 4, right? So because we get 0 over 4, this is not a L'Hopital. It's just a regular old limit. This is just 0 over 4, which is 0, and you're done. Right? Nothing to do there. All right. I'm going to kind of bracket this guy off so that we can do the next one. So the next one, if we plug in a 0, what do we get on top?
0.
What do we get on the bottom?
0.
This is a L'Hopital. So the first thing we do whenever we're going to L'Hopital is, I'm going to put a little arrow so you know that this is connected. So we have to justify it. The way you justify it is you write the limit as x approaches 0 of the top equals 0, which equals the limit as x approaches 0 of the bottom. Now, personally, I also would recommend you always write, therefore, L'Hopital applies. I'm going to be looking for this on your test, so make sure you know how to justify. All you have to do is show me that both the top and the bottom approach 0, or both the top and the bottom approach infinity. All right. Once you have justified that L'Hopital applies, to apply it, you rewrite your limit, and you take the derivative of the top over the derivative of the bottom. Now, the derivative of the top, this is 1 over 5x plus 2. So I personally would just rewrite this as 5x plus 2 to the negative first. So you might do quotient rule on 1 over 5x plus 2. That's up to you. I would just rethink this as 5x plus 2 to the negative first and do power rule. So the derivative of 5x plus 2 to the negative first is negative 5x plus 2 to the negative second times what? Times 5 because of chain rule, right? What's the derivative of a half? 0. Over, now you do the derivative of the bottom. What's the derivative of x? 1. It's the derivative of the top over the derivative of the bottom. It's the only time you get to have a quotient and not do quotient rule. It's when you're doing a L'Hopital. All right, so if we clean this up, bless you, we get negative 5 over 5x plus 2 squared. When you plug in a 0, what do you get? Negative 5 fourths. Is that what we got the first time we did the limit?
Yeah.
Yes, it is. If we did it right, right? Okay. All right. Good. The next one, if I plug in a 5 to the top, what do I get? 15. If I plug in a 5 to the bottom, what do I get? 0. Is this a L'Hopital?
No.
No. So if it's not 0 over 0, it's a DNE. So this is just DNE. We're done. All right. The next one, if If I plug in a 0 to the top, what do I get? If I plug into the bottom, what do I get?
0.
Is this a L'Hopital?
Yes.
Yes. So go ahead and take a minute, write your justification first. All right, does everyone have their justification written? Right? Limit of the top equals 0, which equals limit of the bottom. Everyone okay with that? Therefore, L'Hopital applies. All right, so now we have to actually apply it, which means we have to find the derivative of the top and the derivative of the bottom. So take a minute. I want you guys to find the derivative of the top. Right? Always rewrite your limit statement. Right? I'm going to start by writing lim x approaches 0. And then derivative of the top and derivative of the bottom. Hi, Keegan.
Hello.
All right. So we get limit x approaches 0 of 1 over 2 root x plus 1. When you plug in your 0, what do you get? 1/2. Is that the same as that we got without L'Hopital? Yes, it is. Would you say that's a little bit easier? Yes. Now, I need to warn you, L'Hopital is not designed to make limits easier. It's designed to make limits doable. So don't think that every time you are applying L'Hopital, it's because you want to make your limit easier. It's not. As you will learn on Monday, L'Hopital does not make all limits easier. It just makes us able to find more limits that we couldn't find previously. So it's like it kind of opens some doors for limits that we at first could not find. All right, so there's that one. For those of you who just came in, I'm going to recap again. L'Hopital's rule is a rule that helps us find limits. So we're back to limit world. And what it says is, if you plug in your number and get 0 over 0, or infinity over infinity, you can take the derivative of the top and the derivative of the bottom and have an equivalent limit. That's what L'Hopital says in a nutshell. And what I stress to everyone is whenever you apply L'Hopital, you are required to justify L'Hopital, which means you have to but show that the limit of the top and bottom are both 0, or in a minute, the limit of the top and bottom are both infinity. All right. Next one, if we plug in an infinity on top, what do we get? We get infinity. If we plug in infinity to the bottom, what do we get? Infinity. So for this one, when we justify our L'Hopital, we're going to write the limit as x approaches infinity of 3x squared plus 1 equals infinity, which equals the limit as x approaches infinity of 2x minus 5. Therefore, L'Hopital applies. take a second to find the derivative of the top and the derivative of the bottom. What's the derivative of the top? 6x. What's the derivative of the bottom? 2. So now, if I plug an infinity in, I have 3 times infinity. What's 3 times infinity? Infinity. This is infinity. Last one. If I plug in infinity to the top, what do I get? Infinity. If I plug infinity into the bottom, what do I get? Negative infinity. Can I apply L'Hopital? Yes, absolutely. Signs don't matter. As long as they're both n infinity, it's okay. But you can't do this the three-way string when you're justifying. So to justify this guy, you would have to say the limit as x approaches infinity of the top equals infinity, and you would say the limit as x approaches infinity of the bottom equals negative infinity, therefore L'Hopital applies. I had a class years ago, and the boys in the class for some reason thought it was like really funny to say L'Hopital. And so like they said it all year, L'Hopital. So it kind of stuck. But I always say, L'Hopital. So anyway. All right, so take a second and apply it. What's the derivative of the top? 3. What's the derivative of the bottom? Oh, what's the limit of 3 over negative 2?
3 over negative 2.
There we go. The thing that's nice about L'Hopital is if you forget your horizontal asymptote rules, L'Hopital makes these really quick and easy. So, I mean, they're quick and easy anyway if you know the rules, right? But if you forget your horizontal asymptote rules, if you forget that the degree of the top and bottom are the same, it's the quotient of the leading coefficients, you can L'Hopital it and get the answer real easy. And the other good news is that if L'Hopital is in the multiple choice, then of course you don't have to justify because nobody cares what you write for multiple choice. They just check the answer, right? So if you're doing a limit in a multiple choice, and you can L'Hopital it, and you don't have to write all this kind of stuff, right? You can just zip to the answer. It's only in the free response that you have to write your justification. So yeah, and again, that's fairly recent. They just recently started requiring that justification. So anyway. All right, let's learn about who L'Hopital is. So I know it's not Mathematician Monday, but Monday's a big lesson, and it seemed appropriate to talk about L'Hopital. Before I talk about L'Hopital, I'm going to read the first 2 lines, and we're going to pause for a minute. I'm going to cover this up with a screen so you can't read ahead. So let's see here. Nah. Don't you think it'd be good on the video to have people learn about L'Hopital? All right. So Guillaume I'm terrible with French. Francois Antoine Marquis de L'Hopital. All right, that's as good as it's going to get. All right, so he's a French mathematician. He lived in the late 1600s. In 1691, he became friends with Johann Bernoulli. Now, the name Bernoulli should sound familiar. So, who tutored him privately about infinitesimal calculus. Now, I'm going to sidebar to Bernoulli for a minute. Years ago, the state of Georgia decided to make a requirement that they wanted to improve reading skills. So they made a requirement that every single subject had to assign reading along with the rest of their curriculum. And it couldn't just be like an article, it had to be full books. So in math, the book that we were required to have all of our students read was this book called The 5 Equations That Changed the World. Now, so I read it over the summer, right? Because my students have to read it, I got to read it, right? So I read it over the summer, 5 Equations That Changed the World. I wasn't looking forward to reading it, I got to be honest, and I ended up really liking it. It's a great book. Like if you're ever looking for something to read and you want to enjoy some math nonfiction, right? It's actually really interesting, but it's not just interesting. The guy who wrote it yes, he is good at math, but he's a storyteller. He's a really good storyteller. So what he does is he chose 5 equations, and for each equation, he tells like about the history of that was going on at the time, the life of the mathematician that came up with the equation, why they needed it, how it works, right? All this kind of stuff. Like you read the book, and after you read the book, you're like, you know what? I actually do get Einstein's theory of relativity now. Like you get it. He explains it in a way that really makes sense. So anyway, but I'm sidebarring to this book because, and in all honesty, I don't remember the book it was a long time ago that we read this, and that they only did that for 1 year, and then like the whole state screamed and yelled, and then they stopped the requirement. But anyway, the second chapter is on Daniel Bernoulli and the law of hydrodynamic pressure. And so there's this whole interesting thing about the Bernoulli family, right? And I'm trying to see if I can find a place where I can quote. Here, wait, let me get my glasses on. Or maybe I'll just summarize. Okay. Okay, young Bernoulli, fluids, Isaac Newton, human beings, fluids, breath, fluids, more Bernoulli. No, okay. Anyway, I'm just going to summarize. All right, so Johann was Daniel Bernoulli's dad, okay? And in essence, what happens in the story is Daniel Bernoulli and Johann Bernoulli both enter this math contest. So Europe had this big, giant math contest that they would do every year where they would like publish a problem and all these different mathematicians and scientists would submit solutions, right? So Johann and Daniel both independently submitted a solution to this math contest, right? So Daniel gets the letter. He gets home before his dad does. He gets the letter, and it is a letter saying that both him and his dad have both been awarded first prize for the whole like continent for their solutions to that year's math contest, right? And he is so excited. So his dad comes home, he's like all excited, shows him the letter. Dad, you and I both just won first place on the European math contest, right? Big deal. The dad, Johann, is so angry that Europe, like the whoever the committee is that judges the contest, that the committee would put his son on the same level that he's on. He gets so angry that his son is like elevated to the same level as him that he kicks his son out of the house and says, "You're never allowed back ever again." And so Daniel ends up moving to Russia, and starts working for the University of St. Petersburg, and ends up having does all these amazing contributions while he's there, and meets all these other really interesting mathematicians. But anyway, there's all this interesting stuff about the Bernoulli family, and the contributions made both by Johann and Daniel, both pretty smart guys. Yes?
Isn't mathematics like facts? So how can you have a first place and a second place, either if you're right or wrong?
Okay, so if you have a problem, not a math problem like what's 5 plus 3, but a problem going on in the world, right?
Oh.
Yes, then you can submit different ideas of how to solve this problem,
Using
right?
mathematics.
Yes. Okay. All right. So anyway, so how does this relate to L'Hopital, right? So L'Hopital is friends with Johann. All right. So in 1694, L'Hopital, makes a deal with Johann Bernoulli. He's going to pay Bernoulli 300 francs a year, and in return, Bernoulli tells L'Hopital all of his mathematical discoveries instead of publishing them himself. So L'Hopital was not an extremely gifted mathematician. He wasn't stupid, but he was not super gifted. What he was like a really smart business guy, right? So here's what happens. So he publishes this book in 1696, which dealt with differential calculus and applications related to differential geometry. So in this book, that's where one of the things you find is L'Hopital's Rule, right? So L'Hopital has this book. It's huge. It's really successful. Everyone is like, wow, you are such a genius, L'Hopital, right? Okay. After L'Hopital dies, Bernoulli starts trying to tell everybody, look, L'Hopital didn't come up with any of this stuff. This was mine, right? But nobody believes him because L'Hopital's the one who published it, right? So anyway, so nobody believes him. So then all of a sudden, this manuscript is found in Basel University that dates to 1691 that has almost all the content from the book in it. And it's Bernoulli's, right? So all of a sudden people are like, whoa, you really did come up with this stuff, right? Except that manuscript was not found until 1921. So they were all dead, right? But so really technically L'Hopital's Rule should be called Bernoulli's Rule, but it's not. It was named after L'Hopital, and that's the way it goes, right? So anyway.
It's not a manuscript. 1691.
Yeah.
200.
Yeah. All right. If you ever have an opportunity to take a math history course, I strongly recommend it. When you get into college, you will get some electives to take, especially towards the end. For me, my entire last term of college was all electives because I had finished all my required courses for my math degree, and I just had to get enough credits, right, to graduate. So if you ever are faced with that, where you're like, gosh, I can take whatever I want, and who knows, like, what should I take, right? Of course, I took a PE class just for the heck of it. It was like, you guys call it Phi Ed up here, but anyway. So I took a PE class, but I also took medieval history just to see how that would go. And I took economics because I always hated economics. I kind of wanted to branch out into different areas. That did not go well. I'm not a good person with economics. I'm a mathematician. They just, for some reason, you'd think that they would go hand in hand, and they just don't. But anyway, but math history, so interesting. And you think it's going to be like boring because it's all math, and it's not. These mathematicians had really wacky, weird lives, and you just get to learn about all the stuff that they do and how much they fight and try to like upbeat each other and everything, right? So anyway, interesting class. All right. So I want you guys to take a minute on paper and see if you can justify each of these with L'Hopital's Rule, and then go ahead and find your limits. So take a minute, just on paper, justify each of these, and then work them out with L'Hopital's Rule. Don't worry, there will be more problems to do on your whiteboards. for the first one, first thing we have to do is justify our use of L'Hopital by stating that the limit of the top equals 0, which equals the limit of the bottom. Therefore, L'Hopital applies. Okay. All right. So now we do the L'Hopital. What's the derivative of sine? Cosine. What's the derivative of x? 1. What's the cosine of 0? What's the cosine of 0? 1. So this limit is 1. Very nice, right? Not bad. Next one, we talked about this a few minutes ago. We justify, we already have ascertained that the natural log of 1 is 0. H equals limit as x approaches 1 of x minus 1. Therefore, L'Hopital applies. All right. So, we rewrite our limit. Don't forget to rewrite your limit statement. All right, what's the derivative of ln x? 1 over x. What's the derivative of x minus 1? 1. Plug in a 1, and what do you get? 1. The L'Hopital works really nicely for each of these. You ready to try some?
Sure. Yeah.
Good. Oh, whoops, first, one more on paper, sorry, before we do the ones on whiteboards. Okay. You can L'Hopital multiple times. If you L'Hopital, and after you L'Hopital, you still have a limit that's 0 over 0 or infinity over infinity, you can L'Hopital again. You can L'Hopital 20 times, right? Because each limit is its own limit, so you kind of just treat each one as though it's a new limit. So for this one, if you copy down the problem, I have a hint for you, which is if you plug in a 3 to the top, you get 0, and if you plug in a 3 to the bottom, you get 0. So you don't have to sit there on the calculator and work it out, because I'm just telling you it's 0 over 0. So take a minute, justify this, and then L'Hopital it, and see what happens. Everyone have their justification written? All right, so higher. How are you? What's the derivative of the top?
3x squared minus 8x minus 2.
What's the derivative of the bottom?
3x squared minus 2x.
All right, everyone. 27 minus 24 minus 3. What does that equal?
0.
0. 27 minus 6 minus 21. What does that equal?
0.
We've got another 0 over 0. What are we going to do? Let's L'Hopital again. Now, if we L'Hopital again,
Wait, can you just like factor and then cancel?
yes, we can. Let's pretend we can't. Yes. Okay. He's absolutely right. So he's totally on track. Yes, you can just factor and cancel here. And as a matter of fact, so Keegan, what you were not in the room for, every single one of these limits could be found without L'Hopital, right? You don't have to L'Hopital, but I'm teaching you how to L'Hopital so that when you get to the limits where you do have to L'Hopital, you can do it. So anyway, for this one, we're going to L'Hopital again. When you L'Hopital a second time, you have to re-justify it. So we have to say, okay, well now the limit as x approaches 3 of 3x squared minus 8x minus 3 equals 0, which equals the limit as x approaches 3 of 3x squared minus 2x minus 21. Therefore, L'Hopital applies again. You have to rewrite it. Get used to it. It'll be okay. There won't be like 50 of these on the test, but there will be at least 2 of them. All right, what's the derivative of the top? Everyone just yell it out. Good. What's the derivative of the bottom? All right, so I plug a 3 in on top. I get 18 minus 8, which is 10. I plug a 3 in on the bottom. I get 18 minus 2, which is 16. And my limit is 5/8. Are you kind of seeing how it works? Okay. All right, so these beautiful 4 problems, I want them on your whiteboards with justification. First one, I'm seeing a lot of 1/2s. Actually, I see all 1/2s. So very quickly, whoop, oh. Move this up so this doesn't. Okay. So we have the limit as x approaches 1 of arctan x minus pi fourths. Arctan of 1, that's the angle whose tangent is 1. What angle has a tangent of 1? Pi over 4. Okay, so pi fourths, so equals 0, which equals the limit as x approaches 1 of x minus 1. Therefore, L'Hopital applies. All right.
Miss Price,
Yes.
is there like an interval that we have to do these in? Because like
Arctangent, remember, is only defined with a range from what to what?
Oh, it's
Negative pi over 2.
Negative pi halves to pi halves, right? Yes. Otherwise, it wouldn't be a function. Arctan is restricted. All of your angles have to be between negative pi halves and pi halves. Yes. Do you remember that? Good. That's good, because that's important, right? Okay. So the derivative of arctan x, let's see how well we remembered. It's 1 over 1 plus x squared. Derivative of pi fourths is 0 over 1. Plug in your 1. And you get a half. All right, so well done. You guys all got that. And I see you all remember the derivative of arctan, which is fantastic. So good job. All right, the next one, if we plug in infinity to the top, we get what? Infinity. We plug infinity into the bottom, what do we get? Infinity. So, L'Hopital applies. Okay, so we do a L'Hopital, and we get the limit as x approaches infinity of 2x over e to the x. If we plug infinity into the top, what do we get? We get infinity. We plug infinity into the bottom. What do we get? Infinity. So, I'm going to L'Hopital again. Okay. So this equals the limit as x approaches infinity of 2 over e to the x. Now, if we plug infinity on top, we get 2. On the bottom, we get infinity. What is 2 divided by infinity?
0.
This is 0. Okay. There are other ways to do this problem, but this would be the L'Hopital way, right? Okay. All right. Just kind of a little separation here because, like Keegan, I write big. Okay. So, next one. Okay. Even though Keegan, you really don't write big, you just took up space. Yeah. Okay. So the next one, if we plug infinity to the top, what do we get? Infinity. If we plug infinity to the bottom, what do we get? Infinity, right? So again, we're going to L'Hopital. So we have the limit as x approaches infinity of x squared equals infinity, which equals the limit as x approaches infinity of root x squared plus 1. Therefore, L'Hopital applies. All right. So when we do our limit, derivative of the top is 2x. The derivative of the bottom is 1/2 times x squared plus 1 to the negative 1/2 times what? 2x. Chain rule, right? Goodbye, goodbye. If we clean this up, I'm just going to clean it up. So we have limit as x approaches infinity. So 1/2, that's 2. 1/x squared plus 1 to the negative half, that's root x squared plus 1. So when you plug in your infinity, what do you get? You get infinity, right? 2 times infinity is infinity. This guy's infinity. All right. All of those, not bad. Pretty normal. Let's take a look at number 4. Number 4 is the most fun. All right, so we do limit x approaches infinity of x equals infinity equals limit x approaches infinity. Looks just like the last one, right?
Yes.
Everything's all looking happy. We do our derivatives. We get 1/1/2 x squared plus 1 to the negative 1/2 times 2x. I'm going to cancel the 2's, and I end up with this. Let's try L'Hopitaling again. Let's see what happens. Hey, I don't even have to re-justify because it's the same justification. It's the exact same function, right? All right.
Would you like to draw an arrow?
So that's what I'm doing. All right. So let's L'Hopital again. 1/2 x squared plus 1 to the negative 1/2 times 2x over 1. Cancel the 2's.
You must work forever.
Oh, you got it.
So
I think it's
So everything we did was true. L'Hopital wasn't wrong. The limits are equal to each other. It just didn't help us find them, right? This is one of those lovely circular limits where L'Hopital doesn't help you. So once in a while you find a limit where L'Hopital just doesn't help you. Even though it applies, it doesn't do any good. So how are we going to do this limit? We're going to do it the way that we learned a month ago. Which is when we have a limit as x approaches infinity, we drop all the non-leading terms. And then we say, since x is approaching positive infinity, all of our x's are positive, and the square root of x squared is equal to what? X. So what's this limit? It's 1. So well done, you guys got 1. You wrote nothing but the answer. Now, I will tell you the College Board would call that a bald answer, and they would give you no credit for it. So, yeah, you can't just write the answer and hope for the best, unless it's multiple choice, right? Then they don't care. All right. So anyway, all right, we have one, speaking of College Board, we have one more problem, and then we're done, all right? One more problem, and then you get to enjoy your weekend. So this problem is from the BC Calculus exam in 2013. Why is it from BC? Because in 2013, LHopitals was not an AB topic. It was only BC. Later on, a few years later, they added it to AB. But anyway, it was at the time it was only BC. So this was 2013 BC number 5, part A. I know you don't know differential equations. That's okay. You don't have to know them to do this. Consider the differential equation dy dx equals y squared times 2x plus 2. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 0 equals -1. All you have to know is that this is true and this is true. All right? That's all you have to know. Those two things are true. So for part A, it says find the limit as x approaches 0 of f of x plus 1 over sine x. Show the work that leads to your answer. So I want you in your groups, just write this down, and this down. And I want you to think, not on your, no, paper. All right. So I want you to see if you can figure out first, just think in the context of what we've been doing all day, right? How you might be able to find this limit.
Yeah. No, yeah, I've been running hospital like the entire time.
That's
But I
okay.
realize it's low.
You could put the S in. A lot of people put the S in.
The hospital.
Yeah, his name is Mr. the Hospital.
Oh, really?
Yes.
Yeah.
Yes.
It's like a, seems like a famous wrestler. The hospital. Yeah. So it's a limit is equal to the limit as x approaches 0 of y squared x plus 2 cosine.
Wait. I don't know if it's cosine.
Because the derivative of f of x plus 1 is equal to 0. Because that as x approaches 0.
We have 45 more seconds. Yeah.
So that is -1 squared plus 2 0 plus 2 all over cosine 0 is 1 times 2
Okay, let's talk about this. If I plug a 0 into the top, I get f of 0 plus 1. What is f of 0? -1. What's -1 plus 1? 0. So I get 0 over, what's the sign of 0? 0. Therefore, I can use L'Hopital, right? But I've got to justify it. This is actually from the College Board. The College Board scoring guidelines, first thing that they do is show their justification for their L'Hopital, right? So make sure that you justify using your L'Hopital. Okay, and then they say using L'Hopital. So I always just write L'Hopital plus. Somewhere you got to say L'Hopital, you got to name it, all right? So somewhere we name L'Hopital. All right, so then we got to do the derivative. So the derivative of the top, well, that's f prime. The derivative of the bottom is cosine. Do we have an f prime?
Yes.
We do. What is it?
dy dx.
It's dy dx. It's just called dy dx, right? So what you end up with is you get f prime over cosine. F prime of 0 means you're plugging a 0 in for x. What do we plug in for y?
-1.
-1, because that's what y is when x is 0, right? So you end up with -1 times 2. Oh, except it's squared. So you get 1 times 2. So you get 2 over the cosine of 0 is 1. Your answer is 2.
Apparently it's impossible.
Yeah, it is. Yep. Okay. All right, so that is it. There, this end of the lesson. I'm going to pause.